Good afternoon, everybody. Thank you for your patience. Can everybody hear me? Perfectly fine. Okay. So I am Heidi Vanheerswynghels. I am responsible for the pharmaceutical and medical device business in our company Videojet, which is a global leader in coding and marking. And I'm happy to be here today. I hope you have already enjoyed a nice lunch and the momentarily very sunny city of Paris. No snow, so keep it that way. And the topic of this Learning Lab sessions I would like to talk about is all about barcode quality, specific to serialized packaging. You may have received all a nice packaging, and you see some coding and marking on it. Well, this is a topic I would like to talk about. We'll start with some legislation, just see what the legislations say about barcode quality. We'll have a look of what influences may have on your barcode quality, what norm is there to verify that quality, and then how you can, you yourself as a company, test that. So I hope, in the meantime, you're already all very familiar with serialization and with legislation happening all over the world, whether it's in Europe, US, India, China, Brazil. And if your company needs to implement serialization, I sincerely hope you have already started, because the clock is ticking and deadlines are approaching fast. And we all know those projects tend to take longer than expected, 6 months, but bigger projects 2 years, so it's time you start working on it. Well, what we have learned as a company is that mainly the companies kind of say, well, the coding and marking part, that's the very easy bit. Everybody can do it. I just look for a supplier, I invest in equipment, and I print it. It's not that easy as it sounds, and it's also, people tend to forget this is a crucial part, because if you don't have a code on it, well, you can't serialize, there's no track and trace, there's no patient safety, and in the end, your reputation of your company is gone as well. Okay. So, if we have a look at since we're in Paris, I'm not going to go over all the legislations globally. I will just focus on the European Falsified Medicine Directive and have a look what is stated in there around the barcode quality. So one of the points it says, ensure that the structure and printing quality of the two-dimensional barcode encoding the unique identifier allow for high-speed reading and minimization of reading errors. That's very nice worded, but what does that mean? Luckily for us, they also publicized some technical guidelines and supplements, a little bit further detailing what they mean with that. So one of those is said, okay, manufacturers shall print the barcode on the packaging on a smooth, uniform, low reflecting surface. That's quite clear and obvious. And then they also say that the readability of the data matrix code throughout the supply chain should at least be 1 year after the expiry date of the pack, or 5 years after the pack has been released for sale, whatever comes first. And then they also refer to a quality of printing, an ISO standard. We will come to that topic a little bit later in more detail. And they kind of also specify which parameters you need to test to obtain that quality. So, is there a formula for applying a nice high-quality barcode? What could prevent you from not fulfilling whatever we saw on the specifications in the legislation? What influences are there? There's a couple of them. It's just not just one approach. The first one is the printing technology. You need to figure out, okay, what I'm going to print on, what is best for me, because printing technologies, there's a wide range of printing technologies, thermal inkjet, laser, thermal transfer printing, label print and apply, and you need to look at, for your company, your product, what is the best solution. All have pros and cons. A second important factor is if you're working then with a printing technology that requires ink or ribbon, you have to have a look at that ink. Is it fast drying? Is it resistance to abrasion, resistance to humidity? How good is the darkness of the ink? These are all factors who can influence your barcode quality. Then you're setting parameters. Where will I going to position my product? Are you going to position my printing unit farther away, closer away? What software? How do I communicate? This is all important because it can give some hiccups. A fourth one, very important, a lot of the time underestimated, is your carton quality. Carton quality A can be completely different than carton quality B. It can depend on the glossiness of your cartons, your absorption rate of your cartons, the cleanliness of your cartons. These are all factors influencing your barcode quality. Production environment, again, I know most pharmaceutical medical device companies, production environment is quite under the control, but still, you can have fluctuating temperatures, you can have humidity, you can have electrostaticity occurring. Again, all these have an impact on your barcode quality. And finally, have a look at your line integration, because if you have vibration on the line, again, your barcode quality can go just way out of scope. If you have accelerating speeds, if your speed is not constant, all these factors you should really look at, and also the positioning of your printing equipment. Because if you do not take care of all those factors, this could happen, theoretically. For your help, I have each time tried to include some examples we've seen in the practice and causes and things how to help sorting them out. In this specific example, which is a barcode marked with thermal inkjet technology, which is a drop-on-demand technology, you can compare it with your HP office printer. You can clearly see there's those white lines running through the code. So there can be different causes about that. It's stated already, there can be dust, because you're printing and your carton irradiates a little bit of dust. That dust can go to your print head and clog your nozzles where your ink come out, causing some nozzles not be able to print and having white lines. Also, electrostaticity could cause this, because if you have a lot of staticity on your line, your ink drops could really reflect back to your print head, and then again clog your nozzles, causing again those lines. And then you could have some defects in the print head as well. So it's important in your environment, one of the many parameters, that you have a dust-free and electrostatic-free environment. If you have a look at another example, this time it's laser marking. You can see here, this is the same carton we marked on. We used the same laser equipment. Well, we've marked with different wavelengths. A laser can come in different wavelengths depending on the substrate or product you want to mark in. And if you look here, you can see that one example is more nicer white and the other one is more yellowing. And that's really occurring to the different wavelength. One wavelength is burning more the carton. And we've learned that relating to contrast, because the yellowing one, you will have a poorer barcode quality. So the contrast on the right-hand example is far much better. When we were going through the legislations, we saw that the European Falsified Medicine Directive was also referring to an ISO norm, specifically the 15415. So what is this norm about? It's a method, in fact, for assessing the quality of the data matrix. And it looks at a couple of parameters. To put it plainly, it will look if the white elements are as big as the black elements, if the contrast between the white and the black elements are strong enough, if your data matrix is square. And it will also look that when you have dark elements, that they are evenly dark, that not one is less or more darker than the other one. These are the parameters it's going to look for. And it's going to test each parameter individually, and I would give it a quote, a quality mark. And the combination of that, the poorest one, will result in your overall barcode quality. But what is important? What is important to know is that you have to measure that not on your production line, but at standstill. This is a very specific specification of that ISO norm. Yep. And the minimal grades we are looking for, as was also stated in the Falsified Medicine Directive, would be a minimum of C. Some examples when we see, okay, where could be a failure in your grading and the quality according to this ISO norm. One could be like if you create a barcode on your labeler design on your software and you intend to make, let's say, a GS1 2D data matrix code. Well, there's a specific structure to that barcode. So if you omit, like for instance, the front application identifiers of the FNC in front of that barcode, the system will not recognize it, and you will get a failure. So you will have a wrong structure of the barcode. Visually, it may look like a good, perfect data matrix code, but it will not be able to decode it. It will not know what is really inside that barcode. Another example, let's see if you have like your barcode and it's a little bit damaged. If your barcode is damaged, what could be that, like the previous example we saw, there's some nozzles blocked, so not all the printing is happening. Or there could be even some particles in your carton, even some black particles in your carton that could impact also the look of your data matrix. Symbol contrast, so if you intended to have a nice dark barcode compared to white, and it's like a little bit grayish. Could it be that there's not enough pigmentation on your ink use, so it's not nicely black enough? It could be just that your carton material is very glossy, and if I have a glossy carton material, you don't really see very well the reflectance of your white and black. It blends out a little bit, so that could all impact your quality. And then if it's looking at the parameter for modulation, it could be, for instance, if I'm marking with the laser technology and I have some vibrations on my line, so that your carton goes a little bit like that, that means that my marking distance each time varies. So I'm marking deeper or non-deeper, which could really give an uneven mark and an uneven coloring, for instance. If you have your barcode is not really square, again, could be related to your line integration. If I have accelerations on my line, or my line is not moving at a fixed pace, it could cause your barcode just to be a little bit distorted. And it could also be that if I'm printing a barcode on a very porous material, so a material who absorbs a lot of ink, that my inks just bleed out on my material. Tyvek, if you know Tyvek material, that's so like a typical material which is very porous, and I've put an ink drop on it, it just spreads. Which makes that if I need to mark a nice square cell, instead of a cell I have a big blurb. There's ways to prevent that, you just reduce the amount of ink you spill, but at least you need to know that and you need to be careful. Again, some examples. Oh, I'm going too quick here. There's one missing. This is an example of a laser marking, and some background information perhaps on laser marking for those who are not familiar with it. There are different ways how a laser can mark. A laser can mark dots, circles, like this example you see here, but it can also work in raster mode, and raster mode is then really scribing vertical or horizontal lines. Ideally, you would use raster mode, because then you make nicely squares, so then you have a good barcode quality. The advantage of this methodology is that the speed is a little bit lower. It takes more time to scribe that barcode. So then sometimes we opt for dot marking. But as far as I know, and until science proves me differently, a dot in a square, it doesn't completely fit. You have some leftovers. It doesn't completely fit the square. So what we do then, we kind of try to overlap the dots. Like in this case, we kind of try to overlap the dots 30%, so fulfilling more the square. So it makes you have a better contrast and a better filled square of your barcode. And this example, we're moving again back to the thermal inkjet technology. You kind of see those streaks in your barcode. Now what could be the causes of that? Could be several causes. It could be your carton quality. It could be your ink quality. If your ink doesn't dry quickly enough and then suddenly it comes in contact with your line, then it just makes a streak if your ink is not dry. It could be your environment, like your humidity, the line integration. Like I said, if your carton is moving and it touches your conveyor belt sooner than intended, the ink needs to dry for a certain amount, 0.3 seconds, 0.5 seconds ideally. Well, once you do it faster, then you may get those streaks. And in this case, in this example, for instance, we had some humidity problems where this product was coded. Now, how do I ensure that high quality codes are applied? Which tests can I perform? because carton qualities, you know, as well, they get transport, they get sunlight, they get humidity. So how do I know that? I'm marking this, it's perfectly fine in my factory, but then along the supply chain, how do I know where my carton ends up, that I still have a good quality code? There's some topic, if you go back, I each time go back to the legislation because it all ties together. It does say it needs to be, that code needs to be readable for 5 years or after the expiry date of the pack. So how do I know my code is still readable? Well, we have developed a testing procedure together with an independent German institute. So to test the combination of the printing technologies selected, of your substrate, of your parameters, and your inks. So all that combination, and we just tested out how good is this code, and also during the lifespan of your product. So for that, we have different tests on a wide variety of technologies. So depending on what technology is connected, certain tests can be applied. We can go for light fastness. So it will look how your code withstand UV light, because whatever you use, a code will fade during time. So it will tell you how long your code will last and has a good quality. It will also can tell you how good your code is resistance to water. If you have a cold chain environment, how good the code withstands to that. Abrasion, because your carton sometimes transport, it gets stuck, how good the code remains on your carton, how good it's fixed. The drying time, because in your lines we said ideally you need some time to let the code dry, so how quickly does it dry? And then just the ISO norm, it also tests the ISO standards, so how good the quality of your code is. What I just would like to point out of this test, so normally if standard light fastness tests are performed, they look at a wool scale test. Now a wool scale test goes out from a black square, but it doesn't really suit us in serialization because we're not printing full black squares, we're printing a data matrix code with white and black cells. So that test has slightly been adopted to correspond to that, and we really test a data matrix code to see how the data matrix code withstands UV light, not the black square, which gives a far better indication on how good your code is. And for that, we initiated ourselves some tests. We looked in the market, we asked the suppliers of the main pharma carton qualities to give us samples, and starting some tests ourselves to see, well, how big is that variation? Because I can tell you, the ink is important, the carton is important, drying time. Now, we wanted to find out how big those variations is, and I just would like to show you some examples. This is not the full test, just some extract of the results we obtained, and we really saw a wide variation. So if we start initially just making a data matrix code unique identifier, most of the cartons kind of performed okay. We graded them, we tested them, and they all passed. Once we start introducing the additional elements like drying times, we're starting to see a wide variation. Some cartons performed very nice, other ones just failed the test, need a longer time. So we really saw, hey, okay, there's a big interest and then a big contrast. And then we also saw on the different inks, higher pigmented inks, we obtained also better result than lower pigmented inks. If we went it one step further and also introducing the light fastness test, the results even became, more variations were even shown. We saw that the same inks on different cartons, completely different behavior. And then same cartons with different inks, again, completely different behavior. So it really, and some results were really wide out of one another. So it really proved like, okay, you really need to take every factor in account and test it all. Okay, this just shows you some of the results obtained, and you see it's like a doubling result, so they're way out of one another. And this is then really, if you look at the same material but different inks, again, different results. And then when we went down, of course, the further you go, you light fastest, you can test it in several degrees. You can say my code needs to last 1 year, 2 years, 5 years. The further down you go, you can imagine the further down your results go as well. Luckily, we found enough cartons who passed and could maintain for 5 years or more. But some failed. So in all, to conclude this test, the relevant findings were like for us, okay, every carton is different, every ink is different, combinations give different result, higher pigmented inks get better contrast. Paper quality, carton is really, really very crucial, very important. And yeah, you really have to test the combination of all the factors to be sure. Just don't think that if one carton and one ink pass, it will be valid for all your cartons and your inks you use. It's not the case. Again, some examples. Laser marking, an important factor we found when you make lasers and you scribe, you create dust. And for some of the, if you create dust, you need to vacuum out those dust because otherwise you're polluting your air. And we found out that carton materials, different carton materials create different amounts of dust. You can see this example here. We just marked the cartons and we just put a DESA film on it and then looked how much dust was generated. And you clearly see the difference. Yeah, there's a lot more dust in one carton quality than another. Again, you need to take that into account. And then this example here on lasers, you kind of see again more a whiter marking and a more yellowing marking. This is slightly different than the previous example I showed about a whiter and a yellowing marking. Here we didn't change the wavelengths. Well, all the parameters were the same except we changed the carton here. And we saw that one carton had a nice white result and another carton had a more yellowing result. Now this was really related to the structure of the carton and the ingredients of the carton. The kaolin, the China clay we call it, can, if there's not enough amount of that in your carton quality, then you can get this yellowing effect, this more burning effect because the carton is less protected. Okay. To wrap up, I hope this nice little short video with very nice music kind of summarized everything I kind of said and showed you, I hope I have proven how important it is to test your ink, your carton, your printing technology, combining it together. I'm almost to the end of the presentation. I already told you I work for Videojet, who is the global leader in coding and marking. We have a broad range of different printing technologies, running thermal inkjet, laser, thermal transfer, labor print and apply. We support our customers with validation, IQ/OQ documentation, testing services. We're a global company. We try to be wherever our customers is. We are in 135 countries present with our products, and we have a specific also, for our pharma and medical device customers, we have a specific dedicated team who only focuses on that, whether it's on sales, on project, on support, so we have a dedicated team on that. And to help you further, a little bit of knowledge, we also have a nice Videojet Pharma Line app, which you can download on your Google or Apple, and you find everything on the products, different substrates, different products. Just Google it up, you find the information, you can just say I have a bottle and I want to mark a data matrix code, how could it look like with different technologies. You can find all that nice information there together with some case studies, white papers. Should you have any further questions, we also have a booth here, K45, or you just can ask me and come and find me. So I thank you for your time.